Welcome everyone. We're on the last part of vertical projectile motion, and today we're going to revise everything we know. So we're just going to quickly go through what you've done. Okay, so here we go. In vertical, why do objects that fly through the air have the same sort of motion? This is all about vertical projectile motion. This is all about objects that get thrown and get dropped and get bounced, and we all know it turns into a bit of a nightmare for some of us, but it's a nice section. Okay, we've gone through all the bits and pieces, now we're going to put it all together. What have we learned? Well, we've done the definitions. There's quite a few, but we're going to revise those again. We've got the equations, which luckily are given to you on your information sheet. And of course, we've got to remember acceleration due to gravity. We looked at graphs. And of course, then there's that last little bit of bouncing balls, which we don't always like, but it's okay. Our keywords are vertical projectile motion. We're going to define it again for you. We've got acceleration due to gravity and graphs of motion. Those are all the keywords and the key points that we're going to go through. So let's remind ourselves of the important definitions. The first one is, what is a projectile? Well, it's any object that has been thrown or projected or dropped from a height above a surface, and it should be above a surface, and it is called a projectile. I know this definition feels funny because a projectile, you think of something being thrown, but basically anything that's moving in the air is called a projectile. Whether it got dropped, whether it got thrown, it doesn't matter. It's just got to be moving through the air. Then we've got what is free fall, and an object is in free fall when the only force acting on it is the force of gravity. This is another definition that feels a little weird because we think of free fall as being something falling, but it's not. If I throw something up in the air and now the only force acting on it is gravity, we call it free fall. It will eventually come back down, okay? Then we've got terminal velocity, and this is the velocity, is the constant velocity that a free-falling object eventually reaches when the air resistance prevents further acceleration. Skydivers experience terminal velocity. You have to have something falling from a relatively high height for it to get to that point that it's reached free fall, terminal velocity. Okay, we're not going to work with it too much, so don't stress. Then, of course, we've got our equations. The first one is Vf equals Vi plus A delta t. Remember, Vf is final velocity. Vi is initial velocity. A is acceleration. And for our purposes, it's always acceleration due to gravity. So it's 9.8 meters per second squared. And t, of course, is time. And we use this equation when we have no displacement. So we don't know how far it went. The next one is v squared equals vi plus 2a delta y. Delta y, of course, is displacement. And we use this equation when we're not given time. Then we've got the next equation, delta y equals vi delta t plus a half a delta t squared. Here, we use this one when we don't have Vf. So if we're missing final velocity here, we can use this equation. And the last one, delta y equals vi plus vf over 2 delta t. We use this one if we don't know acceleration. And we can only use this one if the acceleration is constant. And luckily, because of the way we do vertical projectile motion, the acceleration is always constant. Okay? Personally, my personal opinion, I don't like that bottom equation, but we can use it, and it does make life a lot easier in this section because we know acceleration is constant. Remember, we're dealing with vectors. Vectors mean direction is very, very, very important. It's the thing that's going to trip you up in this section when we get to problems. We also need to remind ourselves that acceleration due to gravity always acts down. And it doesn't disappear. Even if when we throw an object up and it gets to the top of its motion, remember, even there, it's experiencing acceleration due to gravity down. It's just changing direction. The Earth is always pulling us. We always have a force of gravity. This value cannot disappear, and it always acts down. You'd be surprised how many times I get told it acts up. It is always 9.8 meters per second squared down. Its official symbol is little g. When we do our equations of motion, we keep the acceleration as an a. We don't change it to a g, but it's that value. So, we've done our revision. Now I need to make sure you have some paper and a calculator and a pen, because when we come back, we're going to start getting into the nitty-gritty and doing some equations. So I'll see you in a couple of minutes. Welcome back. Ready to dive in? Hopefully you got your calculators. So let's just get going and see where we get to. All right, so here we go. A projectile is fired vertically upward from a motionless balloon in the air. So that's quite important. The projectile leaves the balloon at a velocity of 200, so that's my initial, and strikes the ground at 300, so that's final. Calculate the height of the balloon above the ground, so that's the first question. Calculate the time it takes for the projectile to reach the ground. When we get a question like this, drawing some sort of diagram is always a good idea, just so we can get it straight in our heads what's happening. And then we can put all the information in, and it makes us not make mistakes with direction. Because direction is important. We have our balloon. There we go. It's motionless. It's a very exciting balloon. We fire the projectile up. There we go. So the projectile is going to go up, and then it's going to come down, and it's going to hit the ground. They tell us that we fire it up at 200 meters per second, and it hits the ground at 300. And that's all they tell me. First thing they want is the height above the balloon. Was that the first one? Yeah, there we go. They want this height. That's delta y. We need to make a decision as to which direction we're going to take positive. This is your choice. I know sometimes people go, you must take down as positive, you must. You don't have to. I like to keep the way I do my questions all the same, so I always take the original direction of motion as positive. That means for this question, I'm taking up as positive. So that tells me my final velocity is minus 300. What they don't tell you is what acceleration is. But we know it's always 9.8 meters per second down. Making a list of what we know is also a good idea. So my final velocity is minus 300. My initial velocity is 200. Oops, there we go. My acceleration is minus 9.8. I don't know time. And I'm wanting displacement. Did I give myself an extra space? There we go. So let's just rewrite that list again. So we know final velocity minus 300 Initial velocity is 200. Acceleration minus 9,8. Time, we don't know. Delta y is what we're looking for. Here, we now need to make a decision as to which equation we're going to use. I can't use any of the equations that have time in them. So I can't use VF equals VI plus A delta T. I don't know T. I can't use delta Y equals VI delta T plus a half A delta T squared, because it has T in it. And I can't use the last equation either that we had with the half in it, because it all requires time. There's only one equation I can use that doesn't have time in it, and it's this one. VF squared equals VI squared plus 2A delta Y. It's not pleasant because it's got the square in it, but it doesn't matter. Please be careful. Now, this is a note. I've made a positive. I know that when I put in the minus 300 into the V squared, when I square it, it's going to end up being a positive. That doesn't matter, okay? You still substitute in the negative because it is negative. Oh, no, not plus. That should be equal. There we go. Let's equal to 200, remember, also minus 9,8. So we're going to do minus 300 squared, and that gives us 90,000. Oh, 90,000, extra 0. Let's do the 200. Okay, that is 40,000. Then I'm going to have 2 times 9.8, 19,6. I need to solve for delta y. So if I bring the 19,6 over, that becomes positive. I'm going to have, I was going to do that the wrong way around, so let's just make sure I get it right. So now we're going to have 40,000 minus 90,000. And of course, I'm going to need to have delta y on its own. So let's just do it here. So we've got 40,000 minus 90,000. And we get minus 50,000. And we're going to divide by 19,6 on both sides. So we're going to take that answer, divide by 19.6, and I get minus 2,051,02. Minus 2,051,02. We need to interpret this now because delta y is negative. And now you're going, but they asked for a height. How can it be negative? Remember, my balloon was here and it drops down. So this negative is telling me that it ended 2,551 meters below where it started. They wanted the height of the balloon. We need to interpret this answer. Therefore, the height is 2,551,02 meters above the ground. That's very high. That's 2.5 kilometers, okay? There wasn't somebody in this balloon. It feels funny because you got a negative. It's just because I took up as positive. If you had taken down as positive, you would have got a positive answer, And your substitution, where I have a negative, you must have a positive. Where I have a positive, you must have a negative. We're going to do the next question, and here you've got to be careful. I took up is positive the whole question. It can't change. We can't change our mind, okay? Now they want to know the time it takes for the projectile to reach the ground. Here, we have lots of options. We know delta y now, so we can actually use any of the equations. But let's be logical. Let's use the simplest. I'm not going to use the one with t squared in it, because then I'm going to have a quadratic equation. I'm lazy. I don't like that maths. We could use the last equation with delta y equals vf plus vi over 2. It's also too much like hard work. Easiest equation. Also, this equation doesn't rely on my answer for the first equation. So it doesn't matter now if I got the first equation wrong, because I don't need that information to do the second equation. If we can avoid using something we've worked out already, we need to do that, so we don't have a carry down error. If you carry it down, they'll mark it anyway, but we want to try avoid that. We still can't forget about our directions. VF is still minus 300. VI is 200. A is minus 9,8. Okay? So I'm going to take the 200 over. (9,8). So this tells me I've got minus 500. I'm sure you guys can all do that. Minus 9,8 delta t. I need t on its own, so I'm going to divide both sides by 9,8 minus 500 divided by minus 9.8 gives me 51,02 seconds. At this point, 51,02. Time is a scalar. When you work out time, you must get a positive answer. If you do this calculation and you end up with a negative time, you can't just change it to positive because you know it's got to be positive. You've made a mistake. Something's gone wrong. And more than likely, you've made a mistake with your acceleration or with one of your velocities. You've forgotten that one of them is in the opposite direction, so you've left out a minus somewhere. Please, 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 you've got to make a big NB, big note of this. Time cannot be negative. Negative time means you've made a mistake. As much as sometimes we want to go back in time, we can't. Well, not yet. You never know. Maybe one day we can. But we can't for now. First question, done. Let's do another one. Here we go. A man fires a projectile X, whatever that happens to be, upwards at a velocity of 29,4. So that is my initial velocity. From the edge of a cliff of height 100 meters. So we have a cliff, and it's doing that. The velocity and the projectile lands on the graph on the ground below. The velocity time graph represents the motion of the projectile X. We're going to ignore friction. We always do. It makes life easier. And there's my graph. Not to scale, but it gives us the information we need. When we look at this, they're telling me my initial velocity is 29,4. They're telling me that it's going to hit the ground over there. I think it's maybe not. We're just going to go with it. Then they say use the graph. Here, we need to be careful. When they say use the graph, it means that either you're going to need to use the gradient of the graph, or you are going to need to use the area of the graph. It doesn't mean take the information from the graph and plug it into the equations of motion. It means interpret the graph. Very important. They want to know that the time that the projectile takes to reach its maximum height. Well, actually, this one's a little different because it's on the graph. I'm using the graph. I don't have to do an equation. It reaches its maximum height when velocity is 0. If my velocity is 0, it's gone to the top of its motion, because remember, it's going to go up, it gets slower, it gets slower, it gets slower, it stops, changes direction, and comes back down. So it's there, and at that point, velocity is 0. So when does it reach its maximum height? At 3 seconds. Straightforward. Now they say calculate the maximum height projectile X reaches above the ground. So we know that it was 100 meters the cliff, and then it went up and then came down. What we have to calculate, this is what they're asking, is this little distance. But we're going to use the graph to do that. I'm not going to use an equation of motion, I'm going to use the graph. From a velocity time graph, I can get displacement by looking at the area under the graph. That means this area, this triangle, that gives me the displacement above the cliff. How do we write this? Well, delta y that we're looking for is equal to the area under the graph. In this case, the area makes a triangle, so we've got to remember, it won't be given to us, that that's a half base times height. My base is 3 seconds. My height is 29,4. We are most definitely putting this in the calculator. All right, so we have 0.5 times 3 times 29.4, and we get 44,1. But that is not my answer. They didn't ask how high above the cliff did it go. They wanted to know how high it was from the ground, from here. So it starts at 100 meters already, and now it goes another 44. So therefore, my height above the ground is going to be 100 plus the 44.1, 144,1 meters. Make sure you read the question. When I read this, it's height above the ground. It's always a good idea to underline the important words. Sometimes, though, what they will do, for example, is they'll write the word above in capitals. If there's any word written in capitals, bolded, or underlined, they are important words. Take note of them. They're trying to help you understand the question. Good. Next. Sketch the position time graph for the projectile X for the time interval 0 to 6 seconds. Use the edge of the cliff as the 0 position. Indicate the following: the time when the projectile reaches its maximum height, the time when the projectile reaches the edge of the cliff. And we're only going to 6 seconds over here. We have to remember something called time symmetry. When I throw an object up in the air, if I catch it at exactly the same place I threw it, the time it takes to go up and the time it takes to come down is the same. So here, it took 3 seconds to get to the top of its motion, which means if it travels another 3 seconds, it's actually reached the top of the cliff again. So this graph is only representing, if we have our cliff, it's only representing that part of the motion because it took 3 seconds to get to here, which means it's going to take 3 seconds to get back down. That's very important to take note of. It means that when we draw our graph, we're actually not going to go below the x-axis. We've taken up as positive. When we draw the graph, it's a sketch. So first of all, you use your rulers for your axes, okay? This is displacement. Okay, measured in meters. There's my 0. This is time. They specifically wanted what happens at 3 seconds, and they wanted what happens at 6. Let's just see if they wanted any other values. That's all they wanted. They didn't need any values on it, which is quite nice. What we now need to remember is our displacement graphs are going to be curves because we have acceleration. We then say to ourselves, okay, what happens when the ball's moving up? The ball's moving up and it's getting slower and slower and slower, so the gradient needs to get less steep. So I know it's going to go, I just want to make sure I don't lose where my 3 is. It's going to, it's not going to do that. That's terrible. Okay, it starts off very fast, and it does that. Gets slower and slower and slower, okay? After 3 seconds, it's now coming back down, so now it's speeding up, and it speeds up till it gets to the 6. At 6 seconds, just leave that there, okay? Sometimes it's better to put the values in afterwards because it's more accurate. That's all they wanted. If they had asked for a value, we could have put that this was 44,1 because we know how far it goes. If they had asked for the entire motion, which they didn't, you need to stop here. The edge of the cliff was 0. If they asked for the entire motion, we would carry on below. I'm going to do it in a different color. The entire motion, this would have just kept going down and down and down and down. I don't know the time. We never worked it out. But it would stop at minus 100 because that was the height of the cliff. It goes 100 below. They didn't ask for this last part, so don't put it in. You need to read your question. The way this gets marked is if you go below the axis, you actually lose a mark. They don't give you a mark for the shape because you've done more than you should have, so you haven't answered the question. Make sure you read the question, okay? And 2 questions down, I think it's time for a break. So I'll see you in a couple of minutes. Welcome back, everyone. We're so excited. We're going to do some more equations, which makes me very happy because it's all maths. So let's just dive right in. Here's our question. An object is released from rest at point X. So over here, and I always do this when I read a question, I'm going to write in what I know. So from rest means initial velocity is 0. Above the ground, in the diagram below, it travels the last 30 meters, so this last little bit, in 1.5 seconds before hitting the ground, and they tell us to ignore air friction. Great. Not a bad thing. What do we know? Because it's falling, we know that the acceleration is 9.8 meters per second down, second squared actually, there we go. And what I'm going to do in this question is I'm going to make down positive because I have an object that's been dropped. It's going downwards, so throughout this question, I'm making down positive. Now, it's different to the question we did before the break, so I made up positive. It doesn't make a difference. All right. First question, name the type of motion described. There's only one type of motion. It's known as free fall. Please, we don't call it projectile motion, even though this is a projectile. We call it free fall. That's the type of motion it is. If they asked you to explain why it's free fall, because the only force acting on it is gravity. It's free fall. Then they say, calculate the magnitude of the velocity of the object at B. We've now got to consider what we know. I know that this little section here takes 1.5 seconds. I know the initial velocity at x is 0, and I want to know what the velocity here is. If I consider the motion from x to b, I really do not have enough information. All I know is the initial velocity and the acceleration it experiences. I do not know how long it takes to get to B, and I do not know the distance to B. That's not useful. If I consider the motion from B to C, I know a little bit more. I know time, I know delta y, and I know A. I don't know C. I don't know what it does when it hits the ground. So if I do my list, which is the one I always do, and I look at this information, so I've made down positive. VI is actually what we're looking for. I don't know VF. I know A, which is 9,8 meters per second squared down. I know time, it's 1.5. And I know delta y, which is 30. I then go through the equations, and I go, which one? I need VI, I need delta y, I need delta t, I know A, it's going to be this one. It's going to be delta y equals VI delta t. I was about to write A. That's nonsense. This is why you look it up on your information sheet, by the way. Plus a half A delta t squared. Substitution now. So we have 30. I want VI. This is 1.5. We have a half times 9,8 times 1.5 squared. Don't forget the square. These little squares get left out all the time. They're very sad. At this point, if you can solve for VI without doing any more of the maths, go ahead and do it, okay? I'm just going to show you all the maths so we understand where I'm getting it from. 30, this is 1.5 VI. I definitely can't do this one in my head, so we've got 0.5 times 9.8 times 1.5 squared, and we get 11,025. I'm keeping all the decimals because it's not my final answer. I'm going to need to take that over to the other side. So we're going to get 1,5 times VI. It'll be 30 minus 11,025. And let's see what that gives us. So 30 minus 11.025. And I get 18,975. I'm going to divide by VI on both sides. So I'm going to, 1.5 on both sides, not VI. And I get 12,65. It's a velocity. I would usually say I need to give a direction, but the question said magnitude. In other words, size only. But it's down, and I expected to get a positive answer because at B, there's no way it's going up. It's still going down. So I know it went from 0 to 12,65 meters per second at B. We all good? Now we get the fun question. A ball is now thrown from point X. So we have our object, and now they take a ball and they throw it down. So this is a ball. After the object is dropped, both the ball and the ground hit the ground at the same time. Calculate the time it takes for the ball to hit the ground. We've got to think about this carefully. Normally, we would be able to go, okay, how long does it take the ball to hit the ground? Because we have initial velocity, we have a final velocity, we have heights. We don't have any of that information. The only thing we know about ball B is it got thrown, and it was thrown 1 second after the object. I know a lot more about the object. I know a lot more information about the object. I know that this part takes 1.5 seconds. I know that it's going at 12, let's just remind ourselves, 6.5 over here, and I know this started at 0. So, actually, I could work out the time it takes for X to hit the ground, and then -1 from it. That would be so much easier. I could work out the total distance if I wanted to, and then work out how long the ball takes to hit the ground. I could work out X's final velocity if I wanted to, but let's go the easy route. Let's work out how long it takes for my object, my original object, to hit the ground. Okay? Because if we look at this, all I really need to work out then is this time. How long does it take to go from X to B? Because I know how long it takes to get from B to C. So this, I'm working out. So I'm going to go from X to B. For that little bit of time, I know initial velocity is 0. I know the final velocity is 12,65 because we just worked that out. A is still 9,8. And I'm looking for delta T. We like this because it's a nice, easy equation. So VF equals VI plus A delta T. VF is 12,65. VI is 0. That's an equal sign, not a plus sign. Let's make it look like an equal sign. There we go. Let's do this. There we go. Plus 9,8 delta T. So to get delta T on its own, I'm going to have to divide by 9,8 on both sides. So I've already got the 12.65 divided, make sure you have all the numbers, divided by 9.8, not 98. And we get 1,29 seconds. That tells me how long the object took to get from X to B. I know that it took another 1,5 seconds to get to C. Therefore, the total time for the object is 1,5 plus the 1,29 2,79 seconds. I haven't answered the question yet though. The question was, calculate the time it takes for the ball to hit the ground, and it was thrown 1 second after the object. So if the object took 2,79 seconds to get to the ground, and they hit the ground at the same time, delta t for the ball is 2,79 minus 1. So the ball only takes 1,79 seconds. And I'm happy with it taking a short time because they threw it. If they had dropped the ball, there's no way this would happen. The ball would then hit the ground 1 second after the object, but they threw it. What do we need to see that's the same with these? Because they often have these questions where we have two objects moving. You've got to find what is the same. You've got to find where you can compare them. Sometimes we end up doing simultaneous equations. Sometimes we don't have to, like this one. Okay? Here you had to compare B to something you could find because they didn't give you enough information. Then, okay. Oh, there it is. Okay. So, wrong way. Next question. After hitting the ground, the object bounces once, then comes to rest on the ground. Sketch a velocity time graph for the entire motion of the object. Right. Sketch a velocity time graph. Velocity time graph sketch. Here's my velocity in meters per second. Delta t. It is a sketch. They have not said to you write any values on it, okay? They have not said that to you. A sketch simply means they're looking for the shape. My object was dropped, so initial velocity is 0. We took down as positive, so its velocity increased. Here's the first one. It increased, and it only bounces once. Now remember, we're going to get a change in velocity, and then it bounces once and hits the ground. Bounces once, it comes off the ground, off the ground. It's going to go past there and end there. Okay, I didn't make that quite long enough. That's it. The first part of the graph is when it hits the ground. It changes direction, so the negative velocity shows me that it's changing direction. It's got to go to 0 because it's got to go up to the top of its motion, then it comes back down and it stops. These two lines, mine don't look like it, should be parallel. Why? Because we have the same acceleration for both. Okay? 9,8 meters per second squared down. And that is where we're going to end because we've done lots. Remember, choose your equation carefully. Acceleration due to gravity is always down, and you must choose a direction as positive and stick to it the whole way through. We are done with vertical projectile motion. I'll see you next time.
Siyabangena! Wars and Matrix is back and better than ever. With catch-up lessons, revision and learning support on more platforms than ever before. There are great support materials on the DBE Cloud. Find us on television and revise 10 subjects. And if you miss something, relax, Ntwana. Go to our YouTube channel or DSTV catch-up. Need help? Check out Vele, our Telegram-based chat platform where teachers are waiting to help you. Prefer WhatsApp? Send questions or voice notes to our Waza Matrix WhatsApp line. And that's not all. Want to test yourself? Check out the Matric Live app. Hey Matrix 2021, we've got you covered. Confused where to go? Visit the Waza Matrix website at wazamatrix.co.za. Waza Matrix.
Hey South Africa, September means it's time for Siyavula's annual 1 million maths competition, where you can practice maths and science questions online with great prizes for both learners and teachers. It's a chance for you to learn and win. To enter, sign up at siyavula.com and opt into 1 million maths. Good results in maths and science can open the door to a brighter future. So sign up to Siyavula today and join the competition.